This video is going to have a look at solving simultaneous equations by using a graph. Simultaneous equations are two or more linear lines that have the same solution. So that means all the lines are going to have the same x and y value at the point of intersection, and it's that point of intersection that we are trying to find when we are looking to solve simultaneous equations. So there are a couple ways we can solve simultaneous equations. One way is by drawing a graph and doing it graphically. The second way is algebraically by using either substitution or elimination. In this video, we're going to have a look at the graphical method of solving the simultaneous equations, where we use the graph to identify that point of intersection. So in the first example, we have a graph that has two lines on it. The first line, the red line, is y equals 2x minus 8. The second line, the blue line, is y equals negative x plus 10, and we are looking for the point of intersection. So identifying that point of intersection where our two lines meet, we can then work out what is the solution to those simultaneous equations. So going down from my point of intersection to identify the x value, and I can see the x value is equal to 6. And then going back up to the point of intersection and going back across to my y value, I can see that y is equal to 4. So the solution to this set of equations, where they both have the same x and y value, is 6 and 4. And I can write that as a set of coordinates. I can also check my solution by substituting the solution back into the original equations and make sure that the left-hand side of the equation equals the right-hand side of the equation after I have substituted. So let's have a look and see how we can do that. So having a look at checking the solution and looking at the first equation, y equals 2x minus 8, we want to substitute in our solution to make sure the left-hand side and the right-hand side will equal if we use those coordinates. So looking at the left-hand side, and that is going to equal to y, and I know that my y value is going to be 4. So now I can look at my right-hand side of the equation, and that is going to be 2x minus 8. So substituting my x value of 6, so 2 times 6 minus 8. 2 times 6 is 12. 12 minus 8 is equal to 4. So for the first equation, I can see that my left-hand side is equal to 4 and my right-hand side is equal to 4. So I can see that that balances. I can do the same thing for the second equation. So the left-hand side, again, equals y. So that is going to equal to 4. Looking at my right-hand side, that is going to be negative x plus 10. So substituting in 6, that's going to be negative 6 plus 10, which is equal to 4. So again, I can see my left-hand side and my right-hand side both equal. So I can see there that my solution is correct by substituting them both back into the original equations. So let's have a look at a second example. In the second example, I've got my first line, my red line, which is 2y plus x is equal to 17. And then my blue line, my second line, is y minus x is equal to 4. So having a look to see where those two lines intersect, and then using that to work out what my solution is going to be. So going down from my point of intersection, I can see that x is equal to 3. Then going across from intersection back to the y-axis, I can see that y is equal to 7. So my solution for my set of equations where they intersect is going to be 3 and 7. Again, writing them as a set of coordinates. So I can do the same thing and go ahead and check that my solution is correct. So taking my x value of 3 and y value of 7 and substituting into the equation. So the left-hand side of the first equation is equal to 2y plus x. So substituting in, it's going to be 2 times 7 plus 3. 2 times 7 is 14, plus 3 is equal to 17. The right-hand side of the equation is equal to 17, so I can see that both sides equal each other. Doing the same thing for the second equation, the left-hand side is going to equal y minus x, and substituting in my values, it's going to be 7 minus 3, which is equal to 4. the right-hand side of the equation is equal to 4, so I can see that both sides of the second equation also equal. So there are a couple of examples of how we can solve simultaneous equations by looking at a graph and identifying the point of intersection, and then substituting back into the original equation to be able to check the solution.